let's cover some angle properties review. So in geometry, you had a lot of experience working with angles. You probably did angles until you wanted to puke. You saw angles so much. So there's a couple of reminders of things that you need to know. The first one is something called vertical angles. So vertical angles are the angles that make the x. So let's see if I can draw right here. Okay. So vertical angles are the angles across from each other. These angles are always congruent. So if this angle is 20 degrees, this angle is also 20 degrees. While we're on it, the other thing to remember is that angles that are on a straight line, so I have one line right here, those angles, those are called linear pairs. Called linear pairs because they make a line. Linear pairs are supplementary. Supplementary means that the two angles will add to be 180 degrees. So the 20 plus this angle right here would have to be 180 degrees. So 20 plus 160 degrees is 180. So this angle would be 160. And then let's see. Oh, look, I have another vertical angle. So this angle would also be 160. Now, my drawing obviously is not to scale, but there you go. Another thing you studied in geometry was a picture that looked like this. You studied this picture a lot. Two parallel lines. So these lines were parallel. Whoops, hold on. And then a transversal. So maybe a line that went this way. And so this idea pops up on the ACT quite a bit. Sometimes it's obvious, sometimes it's hidden. But these lines are parallel. Okay, so then what you have to remember are all the angles that are equal. So with two parallel lines and transversals, you still have vertical angles. Vertical angles are always equal. So if you find an x, think vertical angles. But other things that are equal are things like corresponding angles. So corresponding angles are equal. Or I should say congruent. Congruent means same size, same shape, same measure. Corresponding angles are angles that are in the same position. So if I look at these four angles right here, if I know this angle, it has the exact same measure of the angle that's in the same position down here. So the top right angle. So these two angles would be the same. Now, if I know those, then I could solve pretty much for everything else. So let's say this was a 30-degree angle. That would mean this corresponding angle is also 30 degrees. Then from there, I could fill out the rest of these angles because these two angles make a line. So 180 minus 30 would make this angle 150, which would mean this angle corresponds to the 150. So I've got 150 down here. Oh, look, I've got some vertical angles to fill in. Vertical angles, and then 30. Also notice if you have angles on the same side of the transversal, so we've got same side interior and then same side exterior. Interior means they're inside the parallel lines, outside the parallel lines. Same side angles, whether interior or exterior, are supplementary. So when I was in high school, I would always say same side sup, same side sup. Now you might see a picture like this on the ACT, or this idea might be embedded into another shape because we have several shapes that have parallel lines. So these shapes have parallel lines. I'm going to use the abbreviation for parallel. It's two vertical lines. Squares have parallel lines. Whoa, whoa, whoa. So if you see a square, whatever properties apply up here also apply down here. So I've got parallel lines, so that means these two, the same side, are going to be supplementary. Now it's a square, so all 90-degree angles, but 90 plus 90 is 180. What else? Rectangles. A rhombus. Parallelograms. And trapezoids. Trapezoids have one pair of parallel lines. ACT loves trapezoids for some reason. And then another thing about, oh yeah, angle bisectors. Let's talk about those. If you see this word bisect, it means cut in half. So if an angle gets bisected, it gets cut into two equal parts. We see that language quite a bit. Linear pairs we talked about. And then the other one is if you have a circle, there are 360 degrees in a circle. Whoa, whoa, whoa. In a circle. All right, so let's work a couple of these examples. What is the degree measure of the acute angle formed by the hands of a 12-hour clock that reads exactly 1 o'clock? Okay, so let's look at this. So I've drawn a clock here, and I want to know the measure of this angle, right? Okay, well, clocks have numbers from 1 to 12, and a clock is a circle that's divided into all these segments. So I'm just dividing it up. Now, again, this is my last minute drawing, so it's not necessary, it's not really to scale at all. But I'm telling you that on a real clock, all of these segments would be equal. So how many segments do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 segments. They are asking, what is the angle formed that reads 1 o'clock? Well, when it's 1 o'clock, the big hand would be on the 12, the little hand would be on the 1, so they want to know the measure of this angle. Well, if there are 360 degrees in a circle and 12 segments, I'll divide 360 divided by 12, and I'll get 30 degrees. So each of these angles is 30 degrees. Next one, in figure below, A, B, C, D are collinear. That just means that they're all on the same line. FC is parallel. Oh, look, I'm seeing parallel already. FC is parallel to ED. So these lines are parallel. BE is perpendicular to ED. That's good to know. And they've already made the right angle. What are, and the measures of angle FAB, FAB, so this angle, and EBA, EBA, they're marked, 63.47. What is the measure of angle FCB? So question mark. Now, ACT likes to do this. They like to have all these words and then tell you what's at the very end, but they've also put a question mark here. So that can help speed up the process of reading all the questions by just looking and see, okay, what do they have? Now, I'm going to use what I know about triangles. Let's see if I can zoom in. Nope. I'm going to use what I know about triangles. I know that the measure of that all the angles in a triangle add up to be 180. I also know that 40 and this angle right there are 147 in that angle, the angle EBD. Those are linear pairs. So if I take 180 minus 47, I get 133. Okay? So I'm going to draw, let's call this X up here. Okay, so I'm going to draw that triangle a little bit bigger. Here's the C. This is what I'm trying to find. I just figured out, 180 minus, this is not 133, 147 is just 33, just 33. So we just figured out this angle right here is 33 degrees. So I need to know this one. Okay, well, since this line is parallel to this line, then I can use my angle properties. So I know that this angle and this angle right here are supplementary because they're both on the inside of the parallel line. So if this angle is 90, 180 minus 90 makes this angle 90. And if this angle is 90, which is the angle right here, it's a linear pair with that one at the top, this angle right here. So 180 minus 90 makes this angle 90. And now I have two angles of the triangle. So if you subtract 180 minus 90 minus 33, we get 127. So angle C is 127 degrees. Now there's all kinds of angle puzzles that you could have. So the more that you do, the faster you'll be and the more confident you'll feel as you do these. So here's another one. In the figure below, lines A and B are parallel. So these are parallel. And angles are marked and they want to find X. So look, they've marked everything for me. Again, I'm trying to find X. X is a vertical angle, but I don't have any information here. And these transversals don't really go all the way across, but we can make them. So I'm going to extend this line so that it becomes a transversal, and that's going to give me a little bit more information. So if this is a transversal, then I've just made a linear pair and a triangle. Yay! So let's work on this linear pair first. 70 and this angle are a linear pair. So 70 plus 110 cause a linear pair to happen. And then now I need to know this angle. Whoa. Now if I can figure out this angle, that's really going to help me get the third angle of a triangle. So, let's see. It's interior. Oh, look, this angle and the 135, these are same side interior angles, so they should be supplementary. So 180. Oh, wait, but it doesn't go. Yeah, it does. Yeah, it should. 180 minus 135 is 45. Yeah, same side interior supplementary. Now I have a triangle, so now I can do 180 minus 110 minus 45 to give me X. So 180 minus 110 minus 45 is 25 degrees. All right, so practice your angle puzzles. Sometimes the angle puzzles involve algebra. So the figure below is a rectangle with a line running diagonal from one corner to the other. So the angles created by this diagonal from one corner of the rectangles are marked. What's the measure of the smaller angle? So it kind of looks like the 2a plus 7 is a smaller angle, but I won't really know until I know what actual number it is. But I do need to solve for a. So taking the fact that this is a rectangle, I know that rectangles have right angles in the corners. And these two angles combine to be this 90-degree angle. Add them together, they make the 90-degree angle. So I can set up an equation, 3a plus 3 plus 2a plus 7 equals 90. So now I have an equation I can solve. I've got 5a plus 10 equals 90. 5a is equal to 80. Divide by 5, and a is, let's see, 80 divided by 5, 16. 16 is not the answer, so I need to substitute in and find the smaller of the two angles. So let's see, 3 times 16 plus 3. This angle is 22. 2 times 16 plus 7 is 39. And then I can double check myself. Does 22 plus 39 equal 90? No, so there's a mistake here somewhere. Let's see, 2, 5, 10, subtract and get 80. 80 divided by 5, 16. 3 times 16 plus 3 is 51. Oh, I multiplied wrong. 3 times 16 plus 3. This should be 51. Now 51 and 39 make 90. So what is the angle measure of the smaller angles? 39 degrees. Be careful on this. ACT loves to make that variable one of your answer options, like A, B, C, D. They might make A 16 and then D 39. So make sure you answer the question that is being asked.